Okay, let us first define mutually exclusive events. Events that cannot happen together, or events that cannot happen simultaneously, that cannot occur simultaneously, are called mutually exclusive events. For example, day and night are mutually exclusive on a particular time. You can have either day or night at a particular place. It's not possible to have day and night simultaneously at the same time at a particular place at a particular time. Similarly, when you are going on a road and you have two options, turning left or right, you can either turn left or you can either turn right, irrespective of the fact that you may have the option to go straight. But talking of turning left or right, you can do only one thing. You can turn left or you can turn right. You cannot turn in both of the left and right directions at the same time. So these are also examples of mutually exclusive events. And when you are tossing a coin, either you can get a head or you can get a tail. You cannot get a head and a tail simultaneously in a single throw, in a single toss, right? So getting a head or getting a tail, these are also mutually exclusive events. Let us now define exhaustive events. Exhaustive events are the events which cover all the sample space, which produce all the outcomes that are present in the sample space, all the possible outcomes. The events producing those all possible outcomes are called exhaustive events. And there is a special thing about mutually exclusive and exhaustive events, that when two or more events are mutually exclusive and exhaustive at the same time, then the sum of their probabilities is equal to one. That when we add their probabilities, the answer will be equal to one. And we use this fact in solving many problems on probability. Okay, let us discuss an example. There are four teams in a competition. One from London, other from New York, third from Tokyo, and a fourth from Beijing, and they're playing in a competition. And there are calculated chances of their winning based on their previous history, based on their performance. Uh, the chances of winning the cup are given for the three teams. Chances of winning Beijing are not given, and that is what we have to find. Of the three teams, Tokyo seems to be the strongest team, and the London team seems to be the weakest team. But first, we have to find the value of x, then we can decide which is the strongest of all the four or weakest of all the four. Okay, since all these four events are mutually exclusive and exhaustive, because why mutually exclusive? Mutually exclusive, why? Because only one team will win the cup, no two teams can win the final cup, and exhaustive, that only one of these four teams will win. There can be no fourth or sixth or a team from outside, because these are the only four teams taking part in the competition. So the probabilities of the winning should add up to 1, and we will use this fact in finding the value of x. So we will set up an equation that 0.12 plus 0.23, 0.36 plus, plus x equals 1. So it's a mathematical equation which we have to solve, and we will find the value of x from it. So now 0.1 to 0.23 and 0.36 are adding on the left hand side. We will add them, and the answer will be 0.71. And now we have to find the value of x. We have to take the 0.71 to right hand side. We will take it to right hand side, and when it goes to right hand side, its sign will change. It will become negative. So we will have x is equal to 1 minus 0.71, and when you subtract 0.71 from 1, we'll have our final answer x is equal to 0.29. So the chances of the Beijing team winning is 0.29. So now we can see that the team from Tokyo is the strongest one, and the team from London is the weakest one. Let's discuss another example. Example number 2. In it we have the game of a spinner. You know, when you spin a spinner, it stops. The pointer stops at some region. So there are four regions marked: red, green, blue, and pink. And the probabilities have been given on which area or color the spinner stops. Uh, the sectors or the areas of red, green, blue, pink, they are not equal. That's why the probabilities are different, and we have to find the probability that the spinner landing on pink. So since all these four events are also mutually exclusive and exhaustive, uh, the sum of their probability should be equal to 1, and we will suppose that the probability of the spinner of landing on pink is x, and we will add up all the probabilities including the x and the probability of pink, and we'll put the sum equal to 1. Now 0.2 plus 0.1, 0.4, we'll add these three numbers, and the answer will be 0.7. plus x equal to 1, 0.7 will go to the right hand side, and when it goes to the right hand side, it will be subtracted from 1. So we have this equation next, and when we subtract 0.7 from 1, the answer is 0.3. So this is the chance or the probability of the spinner landing on the pink region. Let's consider another example, example number 3. So there are marbles of 3 colors in a bag: white, yellow, and pink. Isa takes out a marble at random from the bag. So work out the probability that Isa takes out a pink marble. The bag contains 80 marbles. Work out how many white marbles are there in the bag. Okay. Now we have been given the probabilities of yellow and white. These are the probabilities of drawing a yellow, for example, a marble from the bag, and the probability of drawing a white marble from the bag is 0.4, which is greater than yellow. That means white marbles must be greater in number as compared to yellow marbles. Okay, let's do part A first, in which we have to find the probability of selecting or choosing a pink marble. Since all the three events, selecting a yellow marble or a white marble or pink marble, are mutually exclusive and exhaustive, the sum of the probabilities of all these three events should be equal to 1. So we will form an equation based on this, and we'll suppose that the probability of choosing a pink marble is x. So we will have an equation that 0.1 plus 0.4 plus x is equal to 1. X is the probability of choosing a pink marble here. Okay, now 0.1 and 0.4 will add to 0.5, and then we have plus x equal to 1. 0.5 should go to right hand side, and when it goes, it becomes negative. It will be subtracted from 1. So x is equal to 0.5, and we subtract 0.5 from 1, you have x is equal to 0.5. So 0.5 is the probability of choosing pink marble from the bag at random. Now in B bar, he's saying there are total number of 80 marbles, and he's asking how many white marbles are there, and we have been given the probability of selecting white marble from the bag, which is 0.4, and we will use this fact. Okay, now we will write our basic formula of finding a probability. For example, if we have to find the probability of choosing or drawing a white marble, so it will be equal to number of favorable outcomes, which is number of white marbles, divided by total number of outcomes, which is equal to total number of marbles. So our formula in this situation is probability of choosing a white marble should be equal to the number of favorable outcomes, which is the number of white marbles, divided by total number of outcomes, which is the total number of marbles in fact. So on the left we have probability of choosing a white marble, which is given us here in the table, which is 0.5, 0.4, and so 0.4 will come on the left, and number of white marbles we have to find, and total number of marbles is given to be 80. So we will put all these numbers, 0.4 on the left, number of marbles we'll write it as it is because we have to find, and 80 will come below because it is given that the total number of marbles is 80. Now 80 is dividing on the right hand side. When it goes to left hand side, we will multiply 0.4, so that we will have 0.4 into 80 on the left equal to number of marbles, white marbles on the right. We will multiply 0.4 and 80, and the answer will be 32. So thus the number of white marbles in the bag is 32 white marbles. Example number 4, it says the spinner is divided into 4 unequal sectors labeled 1, 2, 3, and 4. The probability that the spinner will land on the numbers 2 and 3 is given in the table. The probability that the spinner will land on 1 is equal to the probability that it will land on 4. So you can see the probabilities of the pointers landing on 2 or 3 is not equal. That's why he's saying that the sectors are unequal. When sectors are unequal, the probabilities are not the same. So what we have to do in this question, work out the value facts. We have to find the value facts. In fact, the probability of landing on 1 or 4 is equal. That means the areas or the sizes of the regions where we have labeled 1 and 4 on the spinner, they are equal. Okay, let's start the question. Since all these 4 events that obtaining landing on 4, 1 or 2 or 3 or 4 are mutually exclusive, that we can land only one of these 4 numbers, and they're exhaustive because these are the only 4 outcomes here on the spinner. There is no other outcome. So the probabilities of these 4 events should add up to 1. So we will set up an equation that x plus 0.3 plus 0.4 plus x is equal to 1. Now x plus x, we will add x and x. They are being adding on the left hand side. They're being added on the left hand side. X plus x will become 2x, and 0.3 and 0.4 are also adding, and 0.3 plus 0.4 will be equal to 0.7. So we'll write 2x and 0 plus 0.7 on the left, and equal to, we have 1 on the right hand side. 0.7 is adding on the left hand side. When it goes to right hand side, it will be subtracted from 1, so we'll take it to right hand side so that you can find the value of x. Now we have to remove that 2 also. First we will subtract 0.7 from 1, and the answer will be 0.3 on the right hand side. Now we have to take 2 to right hand side. 2 is multiplying on the left hand side, and when it goes to right hand side, it will divide 0.3. So x will be equal to 0.3 divided by 2. Now 0.3 is a decimal number. Let's divide 0.3 by 2 by putting in inside the bracket and 2 taking outside. So putting a decimal, and 1 to 1 is a 2. We have 2 below 3. We will subtract 2 from 3. We will have 1 here, and then we'll add up a 0 because we have put a decimal. We can add up a 0 with the number as needed. So it becomes 10. So it will go on 5. 2 5 is a 10, and then we will have 10 here. And when we subtract 10 from 10, we have nil at the end. So division is complete. So that the answer of the division is 0.15. So we have got the value of x, which is 0.15. Thus the probability of the probability that the pointer lands on the number 4 is 0.15.